All right, we're starting section 3.3 here, and we're going to do dividing polynomials and looking at their remainders and using them to find out factors. So we're going to start by looking at dividing using synthetic division. It's typically the fastest and easiest way to do these, but you kind of have to remember how to do it. So whenever we're dividing by something like this, we look here and we see that we have the factor here, or the potential factor, -3. What we want to do is actually do this division using +3. We're going to use the opposite of what is there. And so what I bring this over here and do a 3. So this is bringing this over here, doing the opposite. All right, the opposite sign. And then what I'm going to do is write down all the coefficients in front of each term in this part right here. I'm going to write down all these coefficients. So I'm going to put that 3, put a little box around it. And then so with the x cubed, I have a 1. With the x squared, I have a 4. With the x, I have a -5. And then I have the constant 5 by itself. All right, so I have something like that. If I were missing one of them, like say if that x to the 4th wasn't there, I would put a 0 in for it there. I would have written a 0 right there instead of a 4. You don't want to skip any of them. You want to make sure you get the coefficient for each one. Even if the coefficient turns out to be 0, you got to add it back in and then write them down in that order. Then I'm going to leave a little space, draw myself a line here, and I'm going to bring this first number down. Then what I'm going to do is take this 3 and I'm going to multiply it onto that 1, and I'm going to write the result right there. So 3 times 1 is 3, and then I'm going to add 4 plus 3 is 7. And then I'm going to do the same thing. I'm going to bring that 3, multiply it down onto the 7, and write the result right there, 21. And then I'm going to add 21 plus -5 is going to be 16. And then I'm going to do this again. I'm going to bring that 3 down, multiply it here onto the 16. That should give me 48. And then again, I'm going to add 48 plus 5 is 53. All right. And so when I finish with that and I have that done, I've essentially divided them. This last number is your remainder. And then you can write your result down like this. You bring each one of these 3 numbers here down, and you just go in descending order for powers of x, and we start by reducing what we had by 1. So we started with an x to the 3rd up here, so we're going to do an x to the 2nd. And so we have 1 times x to the 2nd, and then just keep decreasing. 7 times x, and then just a 16, and then we add on our remainder, where we write the remainder divided by the x minus 3 from up here that we were dividing by. All right, and so then there we go. We've got that divided synthetic division done right there. All right, so I'm going to go ahead and do this next one just to show you, and then I'll let you get to work on them. So we're going to do this one more time. Here I have a +2, so I'm going to write a -2 here. Then I'm going to put my little box around it, or half a box. And I'm going to write down all my coefficients. I have an x cubed, an x squared, an x, and then no x right there, x to the 0. So I don't have to put any zeros in because I'm not skipping any of them. So I'll write 6, -1, -5, and 4. So 6, there'd be a -1 there, there's a -5 there, and there's a 4 there. So that's where I got all of those. Leave a little space, write your line across here. Bring the 6 down. So -2 times 6 is -12. I'll write it right there. -1 plus -12 is -13. And then I have -2 times -13. That's a +26. And then I have -5 plus 26, which is a 21. And then I have -2 times 21, which is -42. And 4 plus -42 is -38. So that is my remainder. And then I just use these values here as my new coefficients and reduce my the power of my highest x by 1. So this is 6x squared minus 13x plus 21, and then minus 38 over the x plus 2 there as my remainder. And there's my answer. Okay, so what I'd like you to do is go ahead and try number 3. And then if you finish that, also go ahead and try number 2. And I'll pause it here and see if there are any questions. All right, so taking a look at the next one here, we're not missing any x terms there. We have an x cubed, an x squared, an x, and then just a constant term. So we can bring this 6 over here. This is a -6, so we're going to put a 6 here from this -6 there. And then I'm going to write my coefficients down. So I have a 1x cubed, I have a -14x squared, I have a 60x, and then a -72 for my constant term there. Draw my line down there, bring this first one down. That's a 1. 6 times 1 is 6. 6 plus -14 is -8. 6 times -8 is -48. 60 plus -48 would be 12. And then 6 times 12 would be 72. And -72 plus 72 is 0. So we ended up with a remainder of 0 on this one, which means we can write this as x squared minus 8x plus 12. And then we'd have a plus 0 over x minus 6. But 0 divided by anything is just 0. So we don't actually even have to write that one since we had a remainder of 0. All right, and which is nice because that also tells us then that -6 is a factor of this original, right, of that right there, x minus 6. That thing is actually a factor, and we can take advantage of remainders of 0 to help us factor these kind of things later. All right, let's take a look at the next one. Here we have to add this extra 0 back in because it's missing an x squared term. So we add that 0x in. So we're dividing by x minus 3. So I'm going to put a 3 here. I'm going to write my coefficients, 2x squared, 2x cubed, 0x squared, minus 3x, and then minus 2. Leave a little space, put my line, bring the 2 down. 3 times 2 is 6. 0 plus 6 is 6. 3 times 6 is 18. 18 plus -3 is 15. 3 times 15 is 45. And 45 plus -2 is 43. And so we have a remainder of 43 on that one. And so we can say this is 2x squared. We reduce it by 1 because we had an x cubed. So now we have x squared plus 6x plus 15 plus 43 over x minus 3. All right, there's that one for you. Okay, I'm going to pause and check on any questions and then also see if, let y'all do number 5 here. All right, so let's take a look at this one. We have the x plus 3, so we'll write a minus 3 here. We'll bring all our coefficients down. So we have an x to the 4th, so a 1. We're missing an x cubed, so we put a 0. We have a -13x squared. We're missing an x, so we put a 0. And then we have a 36. So we got to be sure to add those 2 zeros in. Draw our line, bring the 1 down. -3 times 1 is -3. 0 plus -3 is -3. -3 times -3 is 9. -13 plus 9 is -4. -3 times -4 is positive 12. 0 plus 12 is 12. -3 times 12 is -36. And then 36 plus -36 is 0. So we ended up with a remainder of 0. So this becomes x to the 3rd minus 3x squared minus 4x plus 12. And then we had our remainder of 0. So that's what we get when we do the division. Now looking at that, watch what happens if we actually plug that 3 back in, or not that 3, we plug the -3 into our function. So let's do f of -3. All right, we get -3 to the 4th minus 13 times -3 squared, and then plus 36. So if we look at this, -3 to the 4th, well, that's -3 squared times -3 squared. So that's 9 times 9, that's 81. And then we have negative 3 squared is 9. And then 9 times 13, well, 10 times 13 would be 130. And if we take another 13 off of it, we get 117. So we get a negative 117 there. And then we have this plus 36 right there. Okay. And then if we start adding these other, we see that 81 plus 36, that is 117. So we end up with 117 minus 117. That gives us 0. So what we can see here is if we plug this value in, we should note here, and we'll talk about this more in just a minute, is this matches that when this matched that. All right, so that's a match, and that's a match. All right, you see that? So basically, in either one of these cases, we just found that negative 3 is a 0. So negative 3 is a 0 of x to the fourth minus 13x squared plus 36. It's a 0 of that right there. It gave us a 0 remainder when we did the division with it, and it also, when you plug it in, gives you a 0 back, which then leads us to the next part, which is the remainder theorem. And basically what this states is if the polynomial f of x is divided by x minus c, note the minus c, then the remainder is f of c. All right? So this basically tells us we can do that. So if we look at this first one here, we can try this. We're going to first try f of 2, and then we're going to actually try doing this division by x minus 2. So notice those are opposite in signs. So if we try f of 2, we get 2 to the third minus 4 times 2 squared plus 5 times 2 plus 3. So I just plugged in 2 for all of these x's right there, just our normal way. Then we get 2 cubed, that's going to be 8. Then we get 2 squared, which is 4, and 4 times 4 is 16. Then I have 5 times 2, that's a 10. And then I have a plus 3. So what I have here is, I can add these up in whatever order I want, but I usually do the positives first. So I have 8 plus 10 plus 3, that's 21. And 21 minus 16 is 5, not 15, 5. I said 5, I'm writing 15, is a 5 right there. And so according to our theorem, our remainder theorem, this right here should be our remainder if we do the division of that function by x minus 2. So let's try it and see. Since we're doing division by x minus 2, we're just going to write a 2 here. So now this 2 matches, now these 2 matches. This matches with that one. All right. And so we're going to go ahead and do that. I have a 1x cubed, a negative 4x squared, a 5x, and then a 3. Draw my line in, bring the 1 down. 2 times 1 is 2. Negative 4 plus 2 is negative 2. 2 times negative 2 is negative 4. 5 plus negative 4 is positive 1. 2 times 1 is 2. 3 plus 2 is 5. And there's our remainder. And they match. That matches with that right there. And so that worked for us. Okay? So what I would like you to do is go ahead and try number 6 there, where you're doing the same thing. You're supposed to try plugging in f of 4 and seeing what you get, and then actually do the synthetic division to confirm that they are the same. And remember, if the remainder is 0, then what we have found is we have found a 0 of that function, or also known as an x-intercept of that function. All right, so I'm going to pause and y'all go ahead and try number 6. All right, so we're going to go through here, use what we've just come up with and stuff we've done in the past to actually graph this one. So we're going to look at end behavior and things like that. So they tell us that -1 is a 0 of this function. And then they tell us to find any remaining zeros and determine the y-intercept and then graph it. So if we start with this, we can say that -1 is a 0. So what we can do is actually divide it here, synthetic division, using that -1. I have x cubed, x squared, x, and then just a constant term, so I'm not missing any, so I can just write my coefficients down. 1, -2, -1, and 2, just like that. Bring the 1 down. -1 times 1 is -1, then -3, then a 3, then a 2. -1 times 2 is -2, and there we go. We have a remainder of 0. So that worked right out. So it is actually a remainder of 0. That means what we can do is use these new sets of coefficients to write down what our function is once we divide it by x plus 1. And so we get x squared minus 3x plus 2. And then that would be times our x plus 1, since -1 was a 0. So this is still our original f of x. That's our original function right there. We just essentially found one of the factors out of it. We factored an x plus 1 out of it since we had that remainder of 0. And so now what I need to do is try and factor this part right there, the x squared minus 3x plus 2. So I asked myself, is there any numbers that multiply to 2 and add to -3? And the answer is -2 and -1. They'll do it. So -2 times -1 is a +2, and -2 plus -1 is this -3. So we get the -3 and they multiply to that 2. All right, so there I have these 3. Now what I can do is look at these and say, all right, what are my zeros? The 0 here from x minus 2 would be 2. The 0 from x minus 1 would be 1. And then the 0 we were given is that 0 from the x plus 1, which is the -1. They all have a multiplicity of 1 because they all have just a 1 as their exponents up there. So they all have a multiplicity of 1. And then since they have an odd multiplicity, what they do on the x-axis is they cross it. So these are all our x-intercepts, and they're going to cross the x-axis. So I immediately see that I have x-intercepts at 2, at 1, and at -1. I have those 3 x-intercepts. I just got those right here. Now I need to look for a y-intercept. To find a y-intercept, you set x equal to 0. So y equals 0 minus 2 times 0, which is 0, minus 0 plus 2. So our y-intercept is simply just y equals 0. Okay, that's what I did there. Y equals 0. Or not y equals 0, y equals 2. Wrote 2 and said 0. So that's right there. So now we have 3 places where it actually hits. And the only thing we really need left to do to get our basic shape of this graph is to look at the end behaviors. This has a leading term of this x cubed, so it's going to determine the end behaviors. So end behavior is going to be based off of x cubed. It's going to be like x cubed, I should say. It's going to be like x cubed, and x cubed falls to the left and rises to the right. So what that means is we have to be falling over here and rising over here. So if I go through and trace this in, the only thing I can do that's going to fit to this, that's going to be, I'm going to start down here because I have to be falling that side. I've got to go up through there, cut over. I have to come down, go through the x-axis there, come back up to go through the x-axis there, and then go on up like that. And so basically then when I draw it like that, it's the only way I possibly can really draw that is that basic shape. And I've got my basic shape for my graph right there. Okay. So I'm going to go ahead and pause it and see if there's any questions. What you should do is try the next one and see if you can get the basic shape of the graph. And then of course, check it at the back. Just make sure you got the right answer. All right. See if there's any questions.